Today is December 3rd, 2023. This is Ted Doskaris, and this video is a follow-up on the video I had done on the AML GP60 a few days ago. I think it might have been November 30th. And what I intend to do today, or mostly with this video, is show how to resolve the directional operation of this loco when it's on track power. The way that the AML loco, these two GP60s that I bought came, was they apparently would run opposite direction on a track compared to Aristo-Craft locomotives or USA Trains locomotives, and I showed that in the last video. And so what I'd like to address today, or mostly address today, is a way to fairly easily fix that. So right now I'm applying a voltage across the track, and it indicates actually minus 3.5 volts, and that's because I've set it up for now with the positive lead on the outside rail or the right rail, and the negative lead on the left rail, or the outside rail, and I guess I should have said this. The other one was the inside rail. So if this were on a curved track, which is a better way to visualize it, the loco would go from left to right or clockwise direction around the curved track. And this method here is set up is more like what an LGB locomotive would operate, because they are noted for being operating in the opposite direction of a lot of the U.S. type locomotives. So here I've got it set at a low voltage, so you can see the direction of the wheel that it's turning. And right now the wheel is turning counterclockwise, and so the rollers, which have tick marks on them, are turning clockwise. So that means it would be going in the from left to right or clockwise if it were on a circular track. So this is the way AML has set up these locomotives. Now they have electronics installed in these things now that includes a switchboard here, and it has a connector called rail here, and another connector called output to decoder. And this circuit board here is, we might call it a motherboard, and it's made by ESU, the German company. And they have this out to decoder cable going into the motherboard. So that's the main feed from the rails, and it's controlled by a switch here. I think it's this one. So, in fact, it's on the plate here that's on the other side. It would be this switch here. So the switch can switch between rail and battery. So, and the battery terminal would be here if you elected to install the actual decoder. Now, in this case, there's no decoder installed, but there's what's analogous to a dummy board, like Aristo-Craft does with their Revolutions socket, where they say it's DCC ready. And so this motherboard is capable of accepting an ESU DCC decoder. And there's an array of pins around here. And in this particular board, it's more like a dummy, although it has a bridge rectifier arrangement of 4 diodes that's on the other side that can't be seen here. And they're fairly large diodes. So, and then it has 30 discrete smaller diodes, and it has 5 dip switches, or dual inline pin switches, each of which have a slide switch that's labeled on or off. And there are 6 of them on each of the dip switches, so that's 6 times 5, or 30 switches. So it's coincidental that there are 30 switches along with 30 discrete diodes, in addition to the bridge rectifier arrangement, which apparently is in here. So now if you got the ESU decoder, then you'd unplug this thing, and it's on a header pin array, and then you plug the decoder in if you wanted to do that. So this motherboard apparently has a DC-DC converter on it. These components look very familiar to a DC-DC converter. There's a choke here, and apparently ceramic capacitors, and there's a main filter capacitor, and a couple of ICs that are probably dedicated to the, usually it's a PWM type arrangement. So in this case, if the voltage is above about 8.5, the actually it's a little lower than that, the lights can come on. And I've operated on PWM, and it works fairly well, probably because of this large filter capacitor, where the lights will come on with the voltage turned down at a fairly low crawl speed, or even with the loco almost or just above stopped. And so that's an advantage of PWM that Aristo-Craft always lauded. And this loco seems to work okay with that. So at any rate, I wanted to demonstrate how this works with the arrangement like LGB, with this track at plus and this track at minus, and then I'll switch the leads. So I'll increase the voltage now, and we'll see the lights come on. So they start to come on, although not as bright, at about maybe 6 volts or so. Higher than that, maybe 6.5. And the ditch lights are coming on. So I'll run it up to about 9 volts. So here it's almost 9 volts. So you can see the headlight is on the body shell there that I've taken off, and not the tail light. So that's in the direction that AML set this logo up with. So now I'll switch the leads over here. We got almost 9 volts again. Now we can see the ditch lights are off and the headlight is off. And on the back side, the rear light is on. And so that demonstrates how AML had set it up, or I should say, well, yes, how AML set it up. So now what I'll do is run the voltage down so we can somewhere near 3.5 again. So there we go, and we can see the tick marks. So we can see the main wheel here is going clockwise, and which means it's going from right to left or backwards, and the little rollers are going clockwise, as to be expected. So what I'm going to do is, oh, by the way, as far as taking this thing apart, it's fairly cleverly designed, I think. It has 6 places here where screws go into, and then there's 6 mirrored on the other side. These are the screws here, and the 2 end screws, the ones that go into the nose and to the very end of the tail, are the larger ones here, and the smaller screws are the ones in between. And what they've done that's just fairly nice is they've put a little bump adjacent, well, in addition to the ones, or adjacent to where the fasteners are. There's a little bump, and there's also an additional one here with no fastener on it, or intended for it. And so they go into the little bump, helps align this thing, and there's one of them. So that would be, this one would correspond to that hole, whereas the screw would pass through this hole, and likewise for all the other fastening locations. So here's a bump here, and there's a screw fastening. Here's the bump that doesn't have a fastener associated with it, and here is where the screw fastener is over here, and there's a little bump there, and right here is where the bump would go into this dimple, really, and then there's where a screw would fasten. So it helps you align the body shell on the thing, which is kind of clever. And then another nice thing they've done was all the functions are labeled here. So with the wiring, so they've labeled the ditch lights and the motors, front and back, and the headlight and the rail where the power pickup comes from, and the rear light. And so there are a number of ways to fix this thing as far as changing the direction. And one might think that if you change the motor polarity on both motors, that you could do that, and that would be fine, excepting the lights would be on in the wrong direction that the loco is traveling. And in here, what AML has done, they're little wires, very much like USA Trains wires their trucks. However, they're soldered with shrink tube, which makes for an excellent connection, but they don't disconnect like like a USA Trains would. So you'd have to cut the shrink tube and take them off, and being you'd have to contend with both changing the motor direction and where the lights are. That wouldn't be very conducive. And the lights are hooked up apparently along this connector here, and so that's not a friendly way to do it. So the most friendly way to do it is to see where these leads come in here from this rail connector, and we can see that they use wire nuts on here. And what you could do is take the red and black wires and swap them with the respective opposites of the where the wire nuts are. Just be careful not to mix up the other wires, and then you'll have a mess. It'll malfunction. So if you just switch the black and red wire where these wire nuts, where they go into these wire nuts, that would be the easiest thing to do. The other possibility is to take this connector that says out to decoder, and it goes into this connector called X14. And it turns out there's another connector, by the way, called X1. They're both in parallel. When I unplugged this, I checked it with a meter, and they're both in parallel. So this connector can be plugged into this socket or this socket, and the factory chose to use this socket. But what I chose to do was make a cable up to replace this and swap the wires. But in addition to that, this loco, unlike say Aristo-Craft, the so-called prime mover locos, which include the GP40 and the -9 and the E8s and E9s, for example, and SD45, the GP40s, and for example, has what's called a polyfuse in it. And here's a polyfuse I'm going to use, because I'm going to put that in. These are available from DigiKey, and they're rated at 3 amps, 30 volts, as much as 30 volts operation across. And at 3 amps, I believe the actual trip voltage is 6 amps. And so what I've done was I've made up this cable here with the polyfuse, and I bought the very same connectors. And these are Molex microfit. They're called Molex microfit 3mm pitch, which means the space between the pins. Molex microfit 3mm, and they're available from Newark Electronics, and that's where I got them, mail order. And I bought the socket pins that go in there as well. And I don't have a crimper, so I just solder them instead, and then poke the pins into the connector housing. So I put some shrink tube on it. So what I'll do now is I'll pause the video, I should say, and swap the cable. Now I've swapped the cable. I took this factory cable, which is the orange wires, and replaced it with the cable I made up with the polyfuse. And you can see it's connected here to same connector the factory used. And again, you could plug it into either one of these. So I turned the power supply on again, and we've got about 3.5 volts here. And so now it's positive on the outside rail and negative on the inside rail. And we can see that the wheels are going clockwise, and the rollers are counterclockwise, and the rollers are going clockwise. So that means it's going to go from left to right in the forward direction, which is like what Aristo-Craft and USA Trains locos would operate with the polarity on the track as shown here. And so I'll speed it up now. So we can see it has a little over 8 volts there. And the ditch lights are on, and the headlights are on, and the loco would be going from left to right or clockwise if it were on a circular track. And we can see the tail light is off, which is what we want to accomplish. And to get back to this thing, if you wanted to have a decoder, you would get an ESU decoder, because apparently AML and ESU work together to make these circuit boards here. And Tony's Trains apparently has a decoder here. Well, that's just one example where you could get it from. And it's a pin header type decoder. And the sound files that you would want, and apparently they program it for you. And the sound files that you would want would be the EMD 16710 G3A sound file for the GP60. Now, the 710 EMD 710 engine was made in a number of different cylinder configurations, including 16-cylinder, which is what the GP60 used, or 12-cylinder, which is what the GP59 used. And there's another file for that called the EMD 12-710 G3A file that you would ask for if you bought the AML Southern, the locomotive decorated in the Southern Railway scheme. It's a green colored locomotive, and AML advertises that as the GP59. So you keep that in mind if you're going to do that. So there you have it. So that resolved the issue and provided a polyfuse protection. So that resolved the issue of the direction of the loco.